Oh, hi there. Thanks so much for joining up your math learning. It's Tutor Grant. And I don't know if you know this about me, but I get tortured by these types of questions that I don't have enough time to answer in the 1 hour contest that we have. I know. How dare I ask you questions that I can't answer? Well, I'm here to show you that I can answer them. It's just that in the hour that we have to do the questions, I'm so busy giving you help that I don't have time for those last few questions. So it's all your fault. It's not my fault. No, that's not the purpose of this video. The purpose of this video is to have some fun and do some math, and I want to show the solution to question 24 here from this past week's Mass Mastery League, which was a very worthy paper and very excellent in terms of the questions that we got to ask. 8 teams are competing in a tournament. Each plays the other teams exactly once. Okay, so if there's 8 teams, Team A plays 7 games because there's 7 other teams. Team B plays 7 games, but we already counted one, so they play 6. Team C plays 5 games we haven't counted yet, and so on. So this gives you your total number of games, okay? Plus ... 1. It's a triangle number! It happens to be the date today, okay? It's the 28th today when I'm recording this, and 28 is a triangle number, and because I know that 1 plus 2 plus 3 ... plus 7 is equal to 28, I don't need to work that out every time. I just know because I know my triangles. And you'll know your triangles too when you pay attention to them. So 28 is a triangle, 21 is the one less triangle. We get that by taking away the 7, but of course we need that 7. We're going to talk about the number 21 and 28 and stuff in this. Okay, so there's 28 games that happen. All right, and the bottom number here is the total mix of probability of all the things that could happen, and that would be, and there's 28 games, so how many different things that can happen? Well, there's 2 outcomes in each game, so we're going to raise 2 to the 28. Wow, that's a big number. Okay, so we must have some cancellation top and bottom because we don't see huge number down here. We only see powers of 2, and that makes sense that we only see powers of 2. They didn't even allow us to eliminate numbers by putting a number under there like 1, 2, 3, 4 or something that's not a power of 2. So our denominator in the probability is always going to be like the total number of outcomes. Okay, and so in that case, that's going to be 2 to the 28. And we're going to write that as 2 to the 28 for now, because ain't nobody needs to see that number expanded. Okay, we're going to leave it as an exponent, because that's really a really efficient way to write it over there. Okay, carry on now? Yes, let's carry on. So that's our total number of outcomes. We want to know the probability that every team loses at least 1 game and wins at least 1 game. So this is the total number of ways. I'm going to put this over here. The total number of ways to do this. Okay, I don't want to write it out. But we divide those 2 numbers, and that's our answer. There, video done. No, finding that number is very tricky. Okay, it's really tricky. You know what's easier to find than that number? The probability that some team does not. Like the probability that some team wins every one of their games or loses every one of their games. Okay, so there we have like absolute total. So we have 2 to the 28 over 2 to the 28, and then we're going to take away the probability that it doesn't happen. All right? If I tell you that there's a 30% chance of sun tomorrow, there's a 70% chance of rain. I do 1 or 100 minus the probability, and I get the opposite probability. Okay, because these probabilities have to sum to 1. It's a super useful idea in statistics and in probability because it's often easier to calculate one side and not the other side. Like if there's only one way for it to be sunny, but there's like 15 ways for it to be rainy, I'd rather work out the probability of the one way that it's sunny and then subtract that from 100 to find for you the probability that it's raining. All right, so here's 1. 2 to the 28 over 2 to the 28. That's the number 1. That's all the possibilities. And then here, let's do the probability that one team wins it all. But then I have to take away the probability that one team loses all their games. And then I'll have the probability that no team won all their games or lost all their games. Right? No, there's a catch. There's a trick here. Okay? And the trick here is this actually is double counting a few cases. And we need to be very careful about these. What if there's one team that loses all their games and one team that wins all their games? Those two things can both happen at the same time, which is wild, but it's possible. Okay, so we need to account for the fact that we have double counted those cases. Like, one thing that's good to note is it's impossible for two teams to win all their games because every team plays everyone else. So if one team wins all their games, no other team can win all their games. But a team could win all their games and then a team could lose all their games, and those cases have been double counted here, right? We would be counting that in that pile and in that pile. We'd be counting them in both piles. And we don't want to count them twice. So what do we do in this case? Let's remove them from the double removal by adding them in. Probability one team wins and one team loses all. Okay, so if we get the probability that one team loses all while another team wins all of them, and we add that back in because we know we've taken that out there and we took it out there. So we took it out twice, so we have to add it back in. Okay, it's a great problem. It's a really fun problem. So let's keep going. Here's my total. Okay, so this is equal to 2 to the 28 over 2 to the 28. And then we're going to take away the probability one team wins it all. Okay, so there's one way for one of these 8 teams, there are 8 teams, don't forget, to win it all. Okay, so there's only one way for your team to win it all. It has to go win, 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 win in all 7 games that you play. But there's 8 different teams that could do it. Okay, so that is 8 multiplied by what could happen in the other games. Well, there's 28 total games, but we've already counted 7 of them. So that means there's 2 to the 21. Sorry, there's 21 other games, meaning there's 2 to the 21 other ways that those games could be played, divided by 2 to the 28. Okay, and then what's the probability that one team loses it all? Well, that's like 8, because there's 8 different teams that could do this. They have to go lose, 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 lose 7 times. So that's easy to count. There's only one way to do that. But then there's 2 to the 21 ways to play the other 21 games. Note, we're not counting all 28 games because we already know that some team's going to win against that poor team that loses all their games. Okay, and we're going to subtract 2 to the 28. But now how about this weird situation over here? The probability that one team wins it all and one team loses it all. Okay, so there's 8 different teams that could win it all. And after we've chosen that, there's 7 different teams that could lose it all. Okay, so we have to pick those 2 teams, and there's 8 times 7 different ways to choose those. So it can't be the same team, so it's not 8 times 8. All right? Following me so far? And then we've already counted 7 games for one team and 7 games for another team. But don't forget, we already counted one of those games. So one team wins all their games, that's 7 games. One team loses all their games, that's 7 games. But you already counted one of those games because they played it against this team. So we have to go 7 minus 6 to get 15 different games. 28 minus 7 minus 6. And of course, you're noticing that these are all triangle numbers because you notice these things, 21, 15. So we have 2 to the power 15. There's 15 different games that can go any way. It doesn't matter how they go. Those teams are going to necessarily have a mix of win and losses because of what we did with those other teams. And there's 2 to the 15 ways to organize those. And there's 2 to the 28 ways to organize all that. And we're adding this back in. Why are we adding that back in? It's good to pause now and notice why. Because we took it out twice already. We took that out in there and we took that out in there. So we need to add it back in once so that we're only taking that out one time. It's like the antidote to the double removal is the single put back in. Yeah. So let's keep going. All right. So now we come down and then we're going to have this is equal to, let's go over to black. Okay, so we have this is equal to, notice we have one common denominator, which is great. Okay, so we're going to be over 2 to the 28. Okay, and so we have 2 to the 28 minus 8 times 2 to the 21. Well, 8 times 2 to the 21 is just 2 to the 3 times 2 to the 21 minus 2 to the 3 times 2 to the 21 plus 8, I can write, 7, I can write 7 as 7. 8, I can write that as 2 to the 3. And then 2 to the 15 is 2 to the 15. And it's all over 2 to the 28. Now let's put together our powers. So 2 to the 8 is 2 to the, let's take out let's do that as 2 to the 10 multiplied by 2 to the 18. That's my 2 to the 28. I'm just going to split them up. You'll see why in a second. Okay, this one is 2 to the 3 times 2 to the 21. So these make 2 to the 24s because we add the number of 2's that we're multiplying together. We add the exponents together in this case. So this is minus 2 to the 24, but I'm going to write that as 2 to the 6 times 2 to the 18. All right, this one is also minus 2 to the 6, 2 to the 18. A neat trick would have been to put those together with a power of 2, but I've already used enough neat tricks. Plus 7 times 2 to the 18. That's a weird way to write 18, and it's a weird way to write 2 as like a subscript. 7, 2 to the 18, 7 times. So then we have all of this over top of these are all multiply. Okay. All over 2 to the, let's write 28 as 2 to the 10, 2 to the 18, and then you'll notice our top and our bottom all have a common factor, 2 to the 18. So let's get out our cancel pen and cancel the 2 to the 18s on top. Because they're present in every term, they can be canceled. And cancel it down there. There's our smaller 2 to the 10 on the bottom. So 2 to the 10 looks pretty good. Let's write that as over 1024. Okay. And what do we have on top? 2 to the 10 minus 2 to the 6 minus 2 to the 6 plus 7. So 2 to the 10 minus 2 to the 6 twice plus 7. This we can evaluate. Right? This is just equal to 1024. There's our 100%. Minus 64 minus another 64 plus a 7. And that works out to be over 1024. And then we're almost there, everybody. So that's minus, this is 1024 minus 128. No sense in skipping a step here. Over 1024. And that's equal to 1024 minus 121 over 1024. Do I still have paper? No! No, I don't. See, I was working on that one too, but that's something for another video. Okay, and then this all is 903 over 1024. So it's about 90%. It's ever so slightly smaller than 90% chance that like 908. Wait, no, not even 902. No, it's ever so slightly larger than 90%. Oops. Ever so slightly larger than 90% of the time, a team doesn't win it all or lose it all. Okay, 903 over. Let's see if it's in the multiple choice. Hey, it's there! Yay! And the people rejoice. Okay, so I hope you rejoiced as well. And I think this one is the one where we don't add that 7 back in. Maybe it's like there. Maybe not quite. Anyway, They have some tricky answers in there is all I'm saying. And I hope that was fun for you and you got to learn something about probability and you got to see that even when the question is super challenging and I don't get to it, I work hard on it so that I can do these types of questions in the future. Because it's my goal to be 25 out of 25 on these math contests. And to be honest, it's these problems that give me a hill to climb. I looked at the official solution, I reproduced it down here, and then I still had an error. Ha 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 ha. So I have to practice to do. And that's good. It's good. It's good to know what you can improve on. Bye for now, everyone.